Okay, question number 2. 15 milliliters of radiator liquid, which is a mixture of water and ethylene glycol, from a car has a mass of 15.69 grams. Part A, calculate the density of the radiator liquid, show how you calculated it, and also show the units with the answer. Part B, based on the calculation above, is the density of ethylene glycol greater than or less than that of water? Explain your answer. And finally, for C, determine the mass percent of ethylene glycol in the mixture. So let's first do part A. So let's recall the equation to find density. Density is equal to mass over volume. And in this question, it looks like we are given both. So then we can find the density of our radiator liquid. So I'll just denote it as rad liq, is equal to the mass, which is 15.69 grams, and the volume is 15 milliliters. So 15.69 divided by 15 gives 1.046 grams per milliliter. Okay, so now let's do part B. Based on the calculation above, is the density of ethylene glycol greater than or less than that of water? So first, let's recall the density of water. And it's actually pretty simple. It's around 1 gram per milliliter. So that means when we have 1 milliliter of water, if we were to weigh it out on a scale, it would also be equal to 1 gram. So that's pretty easy to remember. And when we have this mixture of water and ethylene glycol, we have a higher density than that of water. So therefore, ethylene glycol is more dense. And now let's do part C. Determine the mass percent of ethylene glycol in the mixture. Okay, so first let's make some assumptions to help us answer this question. We'll assume that X is the mass of ethylene glycol. So in a mixture containing only water and ethylene glycol, we know that 1 minus X is equal to the mass of our water. So these are based on percentages. And if we had 100% of our mixture, then the mass is X, then we know that 100 minus however much of the ethylene glycol there is will give us the mass of water. So now let's plug it into this equation where we know we're trying to determine the mass percent of ethylene glycol in the mixture. So first we need the density of pure ethylene glycol. So let's look that up. and you get around 1.11 grams over centimeter cubed, which is the same thing as grams per milliliter. So now let's make an expression to find out the mass percent of ethylene glycol. So we know the density of ethylene glycol is 1.11, and the mass percent of ethylene glycol is X. And we know the density of water is just 1. And the water is described as 1 minus X. And if we were to add these values up, we get the density of our radiator liquid. So now let's just plug that value in. 1.11x. And I'll just simplify this. This is the same thing as 1 minus x is equal to what we found in part A, which is 1.046. So now let's just solve for x. You end up getting 0.11x is equal to 0.046. So x is equal to 0.4182. So therefore, our mass percent of ethylene glycol is 41.82%. So now let's see what the junior tutor said. And in this problem, the given quantities are the volume of radiator liquid, which is 15 mils, and the mass of the car. Oh, I guess the mass of the radiator liquid is 15.69. So when finding density, it's just mass divided by volume, and they also got 1.046 grams per milliliter. And then they wrote out the density of water is 1000 kilogram per meter cubed, which is the same thing as 1 gram per mil. So they converted their answer from the previous step to kilograms per meter cubed, and they found that the density of ethylene glycol is greater than the density of water. Okay, so that's correct. And now to determine the mass percent of ethylene glycol in the mixture, again, they just use a different units than we did. They did kilogram per meter cubed, but they have the same sort of setup to find the mass percent of ethylene glycol. Okay, and they ended up getting the same answer, which was around 41.8%. So this solution is correct.